how PHC piles are made. Before any skyscraper or bridge can rise, it needs support underground, and that starts with PHC pile. Today, we're inside a factory to see exactly how these high-strength concrete columns are made, step by step, from steel and concrete to finished foundation. Part 1. Building the steel skeleton. Everything kicks off with a bundle of PC steel bars. Quick note, PC stands for Prestressed concrete steel, which refers to the high-strength metal strands that go inside the pile. These bars form the spine of every pile. Once they're locked into concrete, the result is a PHC pile, the finished product. The raw steel arrives at the factory in long, raw lengths and is immediately moved into a cutting machine. This machine uses a combination of mechanical clamping and high-speed blades to slice the steel bars down to the exact lengths required for each pile specification. Once cut, each bar is taken to an electric end header where both ends are pressed and deformed using extreme heat and pressure. This creates gripping heads that can anchor the bar under tension, allowing the pile to be pre-stressed later on. The next stop is the automatic rebar knitting machine. This machine looks like a giant sewing loop on a rotating axis. Technicians feed the vertical PC steel bars into position on both ends of a rounded steel jig. The machine then welds thinner, pencil-sized circular steel rings around the vertical bars, spacing them evenly. These rings stabilize the frame and hold everything in perfect alignment. When the welding is complete, the whole cage, which now looks like a hollow steel cylinder, is taken off the machine and placed into a round base jig. The jig is fitted with bolts and fastening arms to lock the reinforcement cage in place. This jig does two things. It holds the steel frame shape and acts as a mold interface during the casting stage. Part 2. Casting the concrete. Now it's time for concrete. But first, a crane arm picks up the entire jig with the steel cage and sets it into one half of a long cylindrical mold. This mold is made of heavy-duty steel and is split into two matching halves. Once the steel frame is locked into the bottom half, workers manually pour the concrete mix into the mold. The concrete flows around and through the steel cage, and a rotating vibrator helps it settle, eliminating any trapped air bubbles. The goal is even distribution. No voids, no weak spots. When the bottom half is filled, the top half of the mold is lifted into place. Automated bolt fasteners then clamp it shut. A row of machines run along the length of the mold, tightening each bolt precisely and evenly to hold the pressure during the next phase. Part 3. Centrifugal forming. Now comes the part that sets PHC piles apart from ordinary concrete columns. The sealed mold is lifted and inserted into a centrifugal casting machine. Picture a massive horizontal barrel that spins at blinding speeds. Once the mold is locked in, it starts to rotate. Why centrifugal casting? Because spinning the mold forces the heavier concrete to press outward toward the mold wall, compacting it tightly and squeezing out excess water. This creates a denser, stronger outer layer. That layer is what allows the pile to survive underground pressure, chemical exposure, and decades of use without failure. This high-speed spin lasts for several minutes, and when it's done, the mold is removed and set onto a long curing rack. Next, the mold is wheeled into a steam curing chamber, a massive rectangular container where rows of molds are stacked like logs. The chamber is sealed and filled with hot, high-moisture steam. This accelerates the hydration process in the concrete, helping it harden quickly without cracking. After several hours, the chamber is opened. The molds are now holding concrete that's solid, cured, and extremely dense. Part 5. Pre-stressing the tile. At this point, you've got a solid concrete column, but it's not a PHC pile until it's pre-stressed. And here's what that means. The mold is removed and unbolted by workers using automatic bolt removers that loosen each bolt efficiently along the mold's length. Once released, the top is lifted off, then a hoist system picks up the concrete pile, still attached to the jig at the base, and moves it to a hydraulic stressing station. This machine stretches the internal PC steel bars using hydraulic tensioners. The steel is pulled tight, and thousands of pounds of force are applied. While the bars are still under the stress, the concrete holds them in place, locking in that tension. This is what gives PHC piles their name. The internal steel wants to contract, the surrounding concrete resists, and that internal tug of war builds compressive strength that helps the pile withstand massive vertical and horizontal forces once it's underground. Once pre-stressed, the pile is removed from the jig. The jig itself is disassembled, cleaned, and then reused for the next batch. Part 6. Labeling and final curing. Now the pile moves to the automatic labeling station. Here, a mechanical arm prints technical information, batch number, strength rating, dimensions, directly onto the side of the concrete using waterproof industrial ink. Then, in pairs, the piles are lifted and then stacked into pressurized heat curing containers for a second round of curing. This chamber functions like a precision oven. It exposes the piles to even higher temperatures and pressure, finalizing the hydration process and strengthening the bond between the steel and the concrete. This ensures maximum durability in the field. Fun fact: where PHC piles come from. PHC piles first emerged in Japan during the 1950s, developed as a stronger, more reliable solution for dense urban construction and earthquake zones. Unlike traditional driven piles, these were factory-made and under controlled conditions, ensuring consistent quality. Today, they're used across the globe, from subway lines in Seoul to offshore piers in Singapore, because they offer a unique combination of strength, precision, and speed. In the centrifugal forming process, it was originally inspired by the same spinning logic used in pipe casting and even early centrifuges in mining. Engineers realized that if it could separate ore from mud, it could probably make stronger concrete as well. Part 7. Base coating and transport. Before shipment, each pile's steel base is either enameled or painted. This coating prevents corrosion, especially when the piles are used in wet or coastal environments. It also provides better adhesion if the pile is to be anchored in grout or resin during installation. Finally, the finished PHC piles, now fully cured, labeled, and coated, are loaded onto flatbed trucks using gantry cranes. They're strapped down in stacks, ready to be transported to construction sites where they'll be driven into the ground to support massive structures. From a few bars of steel and a bucket of concrete to a high-tech process involving centrifugal casting, steam curing, and pre-stressing, this is how the strongest concrete piles in the world are made. Every step matters. Every machine has a job. And by the time a PHC pile leaves the factory, it's been compressed, spun, baked, and stretched to the edge of material science, all so that the buildings we live and work in have something solid to stand on. Thank you for watching. If you like this deep dive into the world of industrial concrete, hit that like button, share with someone who loves big machines, and subscribe for more behind-the-scenes stories from the factories that build the modern world. I hope to see you in the next one.